Welcome to day 2 of the Unit Circle Supplements Student Notes. The learning targets for this lesson are to be able to find, and this should be review from what we did in lesson 8.3, be able to find the 6 trigonometric ratios of a point on the terminal side of an angle on the coordinate plane. We're going to be doing this, and then we're going to be able, but it's going to change a little bit though, because we're going to have to use the reference angle in doing so. So it's going to tie together what we learned in 8.3 to what we're going to do with what we did with the reference angles in day 1. That's going to be our first learning target that we're going to look at. In the second video clip, we'll be looking at the second learning target, and then eventually the third learning target. We already know the trig ratios. Take a second to fill those out real quick. And you should already know the reciprocal values. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it's the adjacent over the opposite. These you should be extremely familiar with at this point. When we find 6 trigonometric ratios of an angle in the coordinate plane, we must use the point xy on the terminals as the terminal point on the terminal side of the angle. The angle being at the origin from the x-axis to find the trig ratios. We're also going to have to consider what angle, where this angle is located. So for example, in quadrant 1, it's very easy because remember theta prime is theta. And in quadrant 2, remember that theta prime is 180 minus theta, and in quadrant 3 theta prime is theta minus 180, and in quadrant 4 theta prime was 360 minus theta. Knowing those facts helped us to find reference angles. Well, now we're going to have to use those facts in reverse, because when we find the angle using the trigonometry we did in lesson 8.3, so let me give you an example here. I've just set up my triangle. I used my point. I know what this length right here is, and I know what this length right here is. That has a positive height. This has a negative horizontal distance. And I can use tangent inverse or some other inverse, if I know the hypotenuse, to find the angle. Well, I just found the angle inside that right triangle using trigonometry from 8.3. But I don't want that angle. When I'm telling you that the terminal ray is here, I actually want this angle, and you just found theta prime. So how will I find the original angle? I'll reverse this. Since theta prime is 180 minus this, well, then I'm going to have to just set up that equation and solve for theta, my final angle. Let's take a look at that. Note that we find trig values of the reference angle as opposed to the angle created by the point itself, because we're looking at acute angles. We're using SOHCAHTOA, right triangle trigonometry, but our actual angle is not necessarily an acute angle inside a right triangle. So we're solving for the reference angle when we do this. You already know in example 1 how to find all trig ratios, so that's not bad. Example 2, which will be the next video clip, will show you how to find the angle. So here we have this. It's just a review of something we did in 8.3. I could honestly ask you to do it yourself, but I'm going to give one more example of this. So we have x and y. We have the point, negative 3, 6. So we go back 3 and up 6 to our point. That is our terminal point. That is our terminal ray. I'm just going to put this in there for now. There's theta. I don't even care about that. Here's me dropping my line down. Right now I don't care about it. There's theta prime. We should be able to find theta prime, but we'll be doing that in the next example. Well, we already know that this is back 3 and this is up 6. So I already can find 2 of the ratios right now, just from that. From that, that being the opposite leg to theta prime, this being the adjacent leg to theta prime, the tangent of theta prime is 6 over negative 3, which reduces to negative 2. Its reciprocal value, cotangent of theta prime, you can just put theta for now if you want, but the cotangent of theta prime is the reciprocal of that, negative 3 over 6, which is negative 1/2. We're not doing opposite reciprocals, we're not doing perpendicular slopes, we are just doing the reciprocal, flipping the ratio. So I still need to be able to find sine of theta prime and cosecant of theta prime and cosine of theta prime and secant of theta prime in simplest radical form, just like we did in our notes and on the review and on the last quiz. So we have to do Pythagorean's theorem. This is the hypotenuse. A squared plus b squared equals c squared. A squared is 9, b squared is 36, 36 and 9 is 45. Square root of 45 can be broken down to 9 and 5, which is 3 square roots of 5. So our hypotenuse is 3 square roots of 5. Now you can right now, if you know a common scale factor or a divisor, reduce this fraction or to reduce this triangle to another triangle with smaller side lengths. Hey, those are all divisible by 3, then make this a 2, and this a square roots of 5, and this a negative 1. Now you won't have to reduce them. You don't have to do that though, you can still follow, and I am still going to follow this, but those of you who are like, oh, that totally makes sense, that makes life easier, feel free to do that, just make sure you reduce it correctly. So sine of this angle is opposite over hypotenuse, so I have 6 over 3 square roots of 5, which we have a slight problem. I cannot leave my answer like that. First off, it's not simplified. Second off, it's got a radical in the denominator. Well, the 6 over 3 is easy enough. 6 over 3 is 2, and there's the square root of 5 in the bottom, so there's this 2. It's 2 over square roots of 5. But as you know, we can't leave our radical in the denominator, so we rationalize the denominator going back to unit 2, going back to some of these things that we learned, these algebra skills that we learned in the first semester. This gives us 2 square roots of 5 over 5. So my final answer for sine is 2 square roots of 5 over 5. Now if I'm going to find cosecant, I have to flip that. I don't want to flip it and re-rationalize it. I can flip this one, or I can flip this one that was reduced. So that means that cosecant is going to be square root of 5 over 2. If you wanted to do it this way, you'd have 3 square roots of 5 over 6. Well, 3/6 is 1/2. So then we still get square roots of 5 over 2. Cosine of theta. Cosine of theta is adjacent over hypotenuse, so this is going to be negative 3 over 3 square roots of 5. Well, that's nice. It reduces to negative 1 over square roots of 5. But that can't be our final answer because we have to rationalize the denominator. So this becomes negative square roots of 5 over 5. Well, secant is the reciprocal of that. I don't want to have to re-rationalize the denominator, so I'm coming back to here, just like we did in lesson 8.3, and I'm going to flip it here, so now it's negative square roots of 5 over 1, which is just negative square roots of 5 for secant. Please pause the video and try this for letter B. All right, 8, negative 4 is a point located in quadrant 4. So if I am going to find this angle, theta prime, which we will be doing in the next video example clip, we'll need to know that that's theta prime and that it's in quadrant 4. But for right now, I'm not concerned about that. I'm just concerned that it is 8 to the right and 4 down, and that to solve for all the ratios, I need to know the hypotenuse. So I have 8 squared plus negative 4 squared, which is 80, and the square root of 80, I'm going to break down here. Going into 80, I believe is 16. It goes in 5 times, so that is 4 square roots of 5. So I have negative 4, 8, and 4 square roots of 5. The negative 4 being the opposite leg, the 8 being the adjacent leg, and the 4 square roots of 5 being the hypotenuse. Now I can go through and do my trigonometric ratios. Sine of theta prime is opposite over adjacent. Again, if you see a common divisor, divide it, make it simplified already. I've got negative 4 over 4 square roots of 5. Well, I can reduce that. That becomes negative 1 over square roots of 5, which I can't leave like that. But the nice thing about that is I can quickly find the reciprocal value for secant, or cosecant. Cosecant of theta prime will then be negative square roots of 5 over 1, which is just negative square roots of 5. Rationalizing the denominator for this, will give me negative square roots of 5 over 5. So I now have 2 of my 6 trigonometric ratios. Next, I look for cosine of theta prime. Cosine of theta prime, cosine is adjacent over hypotenuse, so this gives me 8 over 4 square roots of 5. Both are positive, so my fraction is positive. This is really reducing to 2 over square roots of 5. I cannot leave my answer like this. But what's nice about this answer is that I can take that and flip that ratio to get secant. Secant, therefore, will be positive square roots of 5 over 2. Rationalizing the denominator here will give me 2 square roots of 5 over 5. Next, we have to find the tangent and the cotangent. And good news, we should not, unless I give you radicals as part of the coordinates, have to do any rationalizing of a denominator, other than maybe simplifying fractions. So tangent is opposite over adjacent, which is negative 4/8, which reduces to negative 1/2. Cotangent, therefore, would be the reciprocal negative 2 over 1, which is just negative 2. And there's all 6 trigonometric ratios for example 1, letter B, of the unit circle, day 2. Please watch example 2.